Good day, everyone. Welcome to Video Learning with Bahagharing Lexi. And today, what we are going to discuss is all about inverse of a one-to-one function. Now, what must I learn today? At the end of the session, learner is expected to determine the inverse of a one-to-one function. Okay. Now, in our earlier discussion about functions, we perform operations involving functions. And one of the operations that we perform is all about composition of functions. Now, here will be a given two functions. F of x is equal to 3x plus 9. And the other one will be g of x is equal to 1/3 x minus 3. And we are going to find the f composite of g and g composite of f for the following pairs of functions. And to do that, when we talk about composition of functions, now f composite of g implies that you have to substitute the value of your x to g of x. And if you are going to perform g composite of f, it is understood that you have to replace x for g of x as 3x plus 9. Okay, now let me show how are we going to find the composition or the composite of the given pairs of functions or pair of functions. Now let's do this example. Given are the following functions. F of x is equal to 3x plus 9, and then g of x is equal to 1/3 x minus 3. Then, if the given is f of x is equal to 3x plus 9, and we are looking for f composite of g, then our x here for 3x plus 9 will be replaced by g of x, and that is 1/3 x minus 3. Okay, thus we do have 3 times the quantity 1/3 x minus 3 plus 9. Okay. Then after that, we are going to simplify. This will be 3 times 1 all over 3x. 3 times negative 3, that is negative 9 plus 9 using distributive property. Thus, we do have 3 over 3x minus 9 plus 9. But remember, 3 divided by 3 is equal to 1. Multiplied by x, therefore we do have x. Negative 9 plus 9, then we do have 0. Therefore, x plus 0, the answer will be x. Meaning to say, f composite of g is equal to x. Now, what about if we are going to find the g composite of f? Now, in this case, our x here for 1/3 x minus 3, the x will be replaced by the function f of x, which is equal to 3x plus 9. Thus, we do have g composite of f is equal to 1/3 times the quantity 3x plus 9 minus 3. And then applying distributive property, we have 1/3 times 3x, that will be 3 over 3x. 1/3 times 9, that will be 9 over 3, minus 3. Therefore, we do have 3x plus 9 all over 3 minus 3. Okay? Then 3 divided by 3, the answer is 1. Times x, the answer is x. 9 divided by 3, the answer is 3. Okay? Minus 3. Therefore, we do have x plus 3 minus 3. But remember, when you are going to get the sum of 3 and negative 3, the answer will be x. Because 3 minus 3 is 0 plus x, the answer will be x. Okay, I repeat. If you are going to get the sum of 3 positive, and then the negative 3, or simply 3 minus 3, the answer will be 0. Plus x, the answer will become x. Now, observing the result, if we are going to get the composite of f, composite of g, the result is x. And if we are going to get the composite, or if we're going to perform G composite of F, then the result is also X. Now, in this case, if the given two functions, after we perform composition of functions and we arrive with X, it is understood that the given two functions are inverse of each other. Meaning to say, 3x plus 9 is an inverse of 1/3 x minus 3. And 1/3 x minus 3 is an inverse of 3x plus 9. Or we can say that f of x is an inverse of g of x. And g of x is also an inverse of f of x for the reason that we arrive a result after we perform composition of two functions equal to x. Okay? Okay, now we found out that our f of x is equal to 3x plus 9 and g of x is equal to 1/3 x minus 3 are inverse of each other. Now, what will happen, or what is the relationship between the domain and the range of the inverse functions? Okay, now I do have here table of values, and then I assigned x as -2, -1, 0, 1, and 2. And then we are going to find now what we are going to find now the value of y when x is -2, -1, 0, 1, and 2 for our function f of x is equal to 3x plus 9. If our x is -2, therefore 3 times -2 is -6, plus 9, the answer is 3. If our x is -1, therefore 3 times -1 is -3, plus 9, the answer is 6. If our x is 0, then 3 times 0 is equal to 0, plus 9, the answer is 9. If our x is 1, therefore, 3 times 1 is 3, plus 9, the answer is 12. If our x is 2, therefore, 3 times 2, the answer is 6, plus 9, the answer is 15. Now, if I am going to use 3, 6, 9, 12, and 15 for the values of x for the second function, which is g of x is equal to 1/3 x minus 3, what will be the result of y? Okay, now let's observe. If our x is 3, therefore 1/3 times x is equal to 1 minus 3, the answer is -2. If our x is 6, therefore 1/3 times 6 is equal to 2. Minus 3, the answer is -1. If our x is 9, 1/3 times 9 is equal to 3. Minus 3, the answer is 0. If our x is 12, therefore 1/3 times 12 is 4. Minus 3, the answer is positive 1. And if our x is 15, therefore 1/3 times 15 is 5. Minus 3, the answer is positive 2. Okay, observing the values of our x and y for f of x is equal to 3x plus 9 and g of x is equal to 1/3 x minus 3. If you are going to observe the values of x in our f of x is equal to 3x plus 9 becomes the value of our y for g of x is equal to 1/3 x minus 3. And the values of y for f of x is now the values of our x for g of x. Meaning to say there is what we call interchanging of elements. Okay, the first element and the second element, or the domain and the range of f of x, becomes the domain and the range interchangeably for g of x is equal to 1/3 x minus 3. That is the relationship between two functions that are inverse of each other. Therefore, from that concept, our definition about inverse function is that let a function f be a one-to-one function, meaning to say only function that are considered to be one-to-one function have or has an inverse function, because we do have two correspondence that can be a function that is one-to-one or many-to-one correspondence. But here, only one-to-one function has an inverse function. As I said, let a function f be a one-to-one function, then the inverse function denoted by f raised by -1 is the set of ordered pairs obtained from the function f by interchanging the first and second elements of each ordered pairs. The first element here is the domain, and the second element here is the range. When you interchange it, then that will become what? That will become the range and domain, or the domain and the range of the inverse of a given function. That is, given f of x is equal to 3x plus 9, observing our x here, the x, okay, is now the values for y, and the values of y now here is the values of x. Okay, and two functions, f of x and g of x, are inverse function if and only if by checking if the given two functions are inverse. Now, for each x in the domain of g, which is g of x, is in the domain of the function f. That is, f composite of g is equal to x, as we performed in the previous example. Okay? And then, for each x in the domain of f of x is in the domain of g. That is, g composite of f is equal to x. This is, two functions are said to be inverse of each other if and only if. Okay? By performing composition of functions, we arrive at a value equal to x. Now, the question here is, what if we are asked to find for the inverse of a one-to-one function? Okay. Now, in finding for the inverse of a one-to-one function, we do have three-step rule. Now, this is the procedure if you are being asked to find for the inverse of a one-to-one function. Because there are cases wherein given are the pair of functions. And then you are just asked to um, determine or verify if the two functions are inverse with each other. And through composition, we can determine or identify if the two functions are inverse. But what if you are asked to find for the inverse of the given function? And this is now the method in finding for the inverse of a function. Step number 1 is to write or change f of x to y. If the given function is already written as y, then you are not going to perform the first step. But if in case that the given function is written as f of x, g of x, h of x, therefore, you have to change that to y. And then after changing or writing f of x to y, then you have to solve the equation for x in terms of y. Okay? And then after you perform the equation for x in terms of y, then you have to interchange x and y. And the moment that you interchange x and y, then the result will be expressed as inverse function. That is, you have to use f raised to negative 1, open and closed, x. That is inverse of a function in terms of x. Okay? Now, here are examples. Find the inverse of the following functions. We do have f of x is equal to 3x plus 9. That is our example in the previous presentation. Second, we do have f of x is equal to x cubed plus 9. This is a cubic function. Next, we do have f of x is equal to the square root of x minus 1. This is a radical function. F of x is equal to x squared. No, f of x is equal to x minus 2 all over 3. This is a linear function. And f of x is equal to x squared minus 4. And this is a quadratic function. Okay? But remember, only one-to-one function has an inverse function. Therefore, for example number 3, which is a radical function, and example number 5, which is quadratic function, we are going to provide restrictions so that we are not going to come up with imaginary solution. And for f of x, since this is for number 5, this is a quadratic function, and the graph is a parabola wherein using horizontal line test, the horizontal line test will touches at exactly 2 points. Okay, therefore, this will become a many-to-one correspondence. That's why we are going to provide restriction so that we are going to come up with the inverse of this quadratic function. Okay, now let's have our example. The first one is f of x is equal to 3x plus 9. Now, using the three-step rule, we do have the first one, write or change f of x to y. That is, this f of x will be written to y, and then we copy is equal to 3x plus 9. Then after that, we are going to solve the equation for x in terms of y. Now here, the positive 9 will be transposed on the left side of our equation, and it will be y minus 9 is equal to 3x. From positive, it will become negative. Okay? Then, the numerical coefficient for our 3x is 3. Therefore, we are going to divide both sides by 3 so that we can able to find the value of our x. Okay, that is y minus 9 all over 3 is equal to 3x all over 3. Then, divide both sides. 3 divided by 3. Therefore, we do have 1 times x. Therefore, we do have x. And then, we just copy y minus 9 all over 3. But remember, class, 9 can be divided by 3. Thus, we can have y all over 3 minus 9 all over 3 is equal to x. And then 9 divided by 3 is equal to 3. And y over 3 can be written as 1/3 y. Okay, therefore we do have 1/3 y minus 3 is equal to x. And then our third step, we have interchange x and y. The resulting equation is now the inverse of the given function. Okay, therefore, 1/3 x minus 3 is equal to y. Then this y should be replaced to f, or the inverse of the given function, f raised to -1. Now, as you observed, y for 1/3 y was changed into x. And then this x was changed to y. But you have to change this y to f raised to negative 1 since when we interchange the resulting equation is now the inverse of the given function f of x is equal to 3x plus 9. Therefore, our answer will be the inverse of a function is equal to 1/3 x minus 3. Okay. Next, another example, we do have f of x is equal to x cubed minus 5. This is a cubic function, and we don't have restriction for the values of our x. Okay? Now, here, we do have our solution. The first step, we are going to change f of x to y. Therefore, we do have y is equal to x cubed minus 5. And then, step number 2, solve the equation for x in terms of y. Therefore, the negative 5 here will be transposed on the left side of our equation. Therefore, we do have y plus 5 is equal to x cubed. Remember, the moment you interchange or the moment, not interchange, the moment you transpose negative 5 on the right, on the left side, therefore, the negative 5 will become positive 5. Thus, we do have y plus 5 is equal to x cubed. And then, x cubed as the exponent of our variable x should be simplified into x raised to 1, which is degree of 1. Therefore, we are going to get the reciprocal of 3 so that our exponent will become 1. We have to get the reciprocal because by multiplying the reciprocal, we are going to get an answer equal to 1. Okay, therefore, we are going to multiply both sides by an exponent 1/3 because the reciprocal of 3 is 1/3. Okay, so that the exponent of the variable x will become 1. Okay, then applying distributive property or applying the concept of power law, therefore, the quantity y plus 5 raised to 1/3 is equal to now 3 times 1 divided by 3. Therefore, we do have 3 over 3. And then 3 divided by 3 is equal to 1. Therefore, we are going to have x raised to 1 or simply x. And remember class, if our exponent is fraction, therefore, we can express this one as a radical expression. Therefore, looking in our denominator, our index is 3. Therefore, we are going to have the cube root of y plus 5 since our index for the exponent 1/3 is equal to 3 for the denominator. Okay? Therefore, we do have the cube root of y plus 5 is equal to x. Then, interchange now x and y. Therefore, the resulting equation is now the inverse of the given function. That is, y will become x and x will become y. But remember, the result should be expressed into an inverse of a function. Thus, we do have the cube root of x plus 5 is equal to y. Since the result is to be expressed as an inverse, our final answer will be the inverse of the given function is equal to the cube root of x plus 5. Okay. Next. Another example, we do have radical function. Now, in this case, if we are going to have an even index, since this is a square root, Therefore, we are going to have restriction for the value of x so that we are not going to come up with a result known as imaginary number. Okay. Now, what is an imaginary number? Imaginary number are those numbers wherein the radicand of the given radical expression for even index is equal to negative numbers. Okay, example of an imaginary number is square root of negative 1. Okay, now what we are going to do here is that we are going to equate now our radicand, which is x minus 1, to x minus 1 is greater than or equal to 0 so that we can able to find our value that will serve as the boundary for the restriction so that we are not going to come up with imaginary solution or imaginary answer. Okay? And then after that, we are going to transpose negative 1 on the right side of our inequality. Okay, we do have x now is greater than or equal to positive 1. Therefore, the value of x here will be from 1 to positive infinity. Okay? And since we already have our restriction for x, then we are going to continue finding the inverse of the given function. Okay, first, change f of x to y, that is, y is equal to the square root of x minus 1. And since our function is square root of x minus 1, then we can rewrite this expression square root of x minus 1 as y is equal to the quantity x minus 1 raised to 1/2. Okay? And then we are going to solve the equation for x in terms of y. And since our exponent is equal to 1/2, then we are going to get the reciprocal of 1/2. And that will be 2. Therefore, both sides will be raised to positive 2. And then, applying the concept of power law, therefore, we are going to have y squared is equal to the quantity x minus 1 closed raised to 2 over 2. How did we arrive with 2 over 2? 1 times 2, that's 2 all over 2. But 2 divided by 2 is equal to 1. Therefore, our answer will be y squared is equal to x minus 1. And after this, we are going to find the value of our x because we are looking for or solving the equation for x in terms of y. That is, transpose negative 1 on the left side of our equation, that is y squared plus 1 is equal to x. And then, third step, interchange x and y. Therefore, y will become x and x will become y. That is, x squared plus 1 is equal to y. Then, the resulting equation is now the inverse of the given function. Therefore, our final answer will be the inverse of a given function is equal to x squared plus 1. Now, remember class, x squared plus 1 is equal to y, or the inverse is equal to x squared plus 1 is a quadratic function. And as a quadratic function, the graph of this quadratic function is a parabola. Therefore, we are going to have restriction in this case because this is a many-to-one correspondence. Therefore, we are just going to get the half of that parabola. Therefore, we are going to provide restriction. And then our restriction for x will be x is greater than or equal to 0. Meaning to say, the values that we are going to assign for x will be from 0 to positive infinity, so that it will satisfy the concept or definition of an inverse function, that is one-to-one function or one-to-one correspondence. Okay? Therefore, the inverse of the given function, square root of x minus 1, is equal to x squared plus 1. And we do have restriction for the radical function for the given, which is x is greater than or equal to 1. While for the inverse of the given function, we do have x is greater than or equal to 0. Okay. Okay, another example that we have here is f of x is equal to x minus 2 all over 3. Now, this function is a linear function wherein we are not going to have restriction for our x. Okay? Thus, we are going to use our three-step rule. Number one, write or change f of x to y. Therefore, this f of x will be written as y is equal to x minus 2 all over 3. And then we are going to solve the equation for x in terms of y. That is, we can have multiplication of our LCD by 3, or we can simply cross multiply. And that will become 3y is equal to x minus 2. And then transpose negative 2 on the left side of our equation. Therefore, we do have 3y plus 2 is equal to x. Therefore, we can now proceed in our step number 3. That is interchange x and y, and then the resulting equation is now the inverse of the given function. Therefore, 3x plus y is equal to 3x plus 2 is equal to y rather. Therefore, x now from y, we change it or we interchange it into x, and then this x is now the y. Therefore, the resulting equation is now our inverse. Therefore, the inverse is equal to 3x plus 2. Okay. Okay, now we do have the last example. We do have f of x is equal to x squared minus 4. And this is a quadratic function. Therefore, in this case, we are going to have restriction. And the x now will be x is greater than or equal to 0. Okay? Therefore, we are now going to proceed in finding the inverse of the given function. We are going to change now f of x to y. Therefore, we do have y is equal to x squared minus 4. And then, after that, we are going to solve the equation for x in terms of y. Negative 4 here will be transposed on the left side of our equation, that is y plus 4 is equal to x squared. Now remember class, the exponent of our x is 2. Therefore, we are going to get the reciprocal of 2 so that our exponent, after we multiply to the inverse of 2, the result will become 1. Okay, for x. Therefore, multiply both sides by 1/2. Okay, then applying the concept of power law, therefore, we are going to distribute the exponent, which is 1/2, and then multiply 2 by 1/2. We have 2 all over 2. Okay, and 2 divided by 2 is equal to 1/2. On the other hand, if the exponent is a fraction, it is understood that you have to express this one into a radical expression. And since our index, which is our denominator, is 2, therefore, we are going to use a square root. Thus, this will become square root of y plus 1 is equal to x. Okay. Then the third step will be change y to x and x to y. But remember, the result of the equation is now the inverse of the given function. Therefore, we do have the square root of x plus 1 is equal to y, and the final answer will be the inverse of the given function is equal to the square root of x plus 1. And remember, class, this is a radical function. Therefore, we are not going to have an imaginary solution. Therefore, our radicand, which is x plus 1, will be equated by x plus 1 is greater than or equal to 0, wherein x is greater than or equal to negative 1. Okay, therefore, the inverse of the given function, x squared minus 4, is the square root of x plus 1. And remember, we do have restrictions for the given quadratic function and then for radical function. Now with this, always remember that two functions are inverse with each other if and only if for each x in the domain of the function g of x is in the domain of f, wherein if we are going to perform composite, which is f composite of g, then the result will be equal to x. That is how we prove that the given two functions are inverse of each other. Or for each x in the domain of f, which is function f of x is in the domain of g. That is, g composite of f is equal to x. And if you are looking for the inverse of the given function, we do have the three-step rule. We have number one, write or change f of x to y. If the given is g of x, therefore, rewrite it into y. If that is h of x, then rewrite it into y. Okay, then solve the equation for x in terms of y and interchange x and y. The resulting equation is the inverse of the given function. With this, thank you, and I hope you're able to learn something in finding the inverse of a one-to-one function. See you in my next video presentation. This is Bahagharing Lexi, waving a beautiful heart to everyone. God bless.